Continuing on with angle relationships here, the next relationship that we are going to look at are supplementary angles. And supplementary angles are angles that add up to 180 degrees. Remember from yesterday, last lesson, 180 degrees is also called what kind of an angle? That would be a straight angle. Which makes sense because 180 degrees is a straight line. So supplementary angles are angles that are going to form that straight line or that semicircle when you make the little swoopity swoop. That was a really bad semicircle, but you get the pic. These also have another name for them. There's a common name that you'll see when you get to geometry in your high school years. They're also called a linear pair. Which kind of makes sense because normally there's two of them. There sometimes can be more than two, though. You can have like three angles that make up 90 or 180 degrees. But two of them that form together a straight line. You know, as you can see in this example here, this angle and this angle together form that straight line, form that half circle, that 180 degrees. Okay, so we're going to use this rule to help us with example number 3 here. I know that I'd be using supplementary here because they're forming a straight line, right? Here we have a straight line or a straight angle. And the more I write down those words and information pieces, the better I am to remember them. So here in this diagram, a little bit different from our other examples because in here we have expressions. We have like expressions with x, algebraic expressions there for the measure of these angles. So what this is saying here, and I'm going to look at this one in green, is angle AOC, well technically the measure of angle AOC, is equal to 3x plus 9. I can't find the measure of that angle because I don't know what x is. And then on the other side over here, we have angle BOC, and the measure of angle BOC is 9x plus 3. Based on the fact that they form that straight angle, based on the fact that if I make the swoopity swoop and then the other swoopity swoop, I'm getting that semicircle, that half circle, that 180 degrees, I know that these angles are supplementary. Meaning they add to 180 degrees. So I can use that to create an equation, which is why we did some equation solving earlier in this unit, that the measure of angle AOC plus the measure of angle BOC is going to be equal to 180 degrees. And now I could just go ahead and fill in my expressions. AOC was being represented by 3x plus 9. BOC was being represented by 9x plus 3. That's a positive 9x, which is why I have the plus sign there. And that's going to be equal to 180. And now you have an equation that you can solve, just like we've been practicing. 9 plus 3 gives me 12. 9, 10, 11, 12. 12x plus 12 equals 180. Minus the 12 to both sides, leaving me with 12x is equal to 168. Final step, divide both sides by 12, leaving us with x being equal to 14. Now careful here, this is not the measure of each angle. And the reason that we know this isn't the measure of each angle, because if we checked that, it wouldn't work. First off, if each of these angles were 14, that would make them equal, and they're not, because you can clearly see they're very different. One has 3x plus 9, the other has 9x. Also, if you did 14 plus 14, that's not going to give you the 180 degrees that it should be. So don't forget, you need to go back and plug x in. Plug x back in to get angles. So coming back over to my diagram where I have this all set up, I've got 9x plus 3 for this blue one. So I'm going to turn that into, I'm going to do it right underneath it. 9 times 14 plus 3. Okay. Well, 9 times 14 is 126, plus 3 is 129. So the measure of angle BOC is 129 degrees. And the measure of AOC, which would be 3 times 14 plus 9. 3 times 14 is 42, plus 9 is 51, making angle AOC 51 degrees, which, if we then checked 51 plus the 129, that gives us the 180 that we would expect. So there's the next main type of relationship that you're going to be using, are supplementary angles, or angles that add to 180 degrees.